Cool. Well, good morning, everyone. So we're going to talk about fine-grained real-time apps with Blazor and Orleans. Um, I'm Sjoerd van der Meer. I'm a coding architect at Xibia, mainly working on basically front-end or web applications. I've got a package called optional values, which adds undefined back into .NET because I think that's like the most awesome feature which is missing in .NET. And I've got like a hobby project which is called Galaxy Sweeper, where you play Minesweeper against each other. So that's also like a real-time app. So we're going to talk about real-time apps. So what do I mean with real-time apps? So basically apps which are low latency, they are event-driven, they allow collaboration. So you will see if you do an action, um, it also you get immediate feedback also for other users. So for example, chat application or collaborative documents, editing, task management, or well, Jira should fix that, but that is all live. Um, or simple Minesweeper games like in the center. So if we want to build a real-time web app in .NET, what would we use? Signal R. Yes. So we're definitely going to use Signal R. At least that's if we're .NET developers, we're going to add Signal R. So in 2018, Microsoft released a real-time web framework. So maybe if someone knows that real-time web framework. So that is Blazor. They don't really tell you that Blazor is a real-time web front-end web framework, but it technically is. So with Blazor, we've got a couple of rendering modes. So the first rendering mode with Blazor is the client interactive mode. And with that, basically all your components and your .NET code is being compiled to WebAssembly, running in the browser, and then it syncs it with JavaScript to the DOM, which is basically the HTML, the stuff you see. Then on the other side, we've got the server interactive mode, where basically everything runs on the server, all your components, and you've got like a Signal R hub, which is then connected to the browser, which makes sure everything renders. So if we zoom into the client mode, basically how we would write our application is that we have our components in the browser, then a server application which is having some API which connects to our private database or internal APIs, and maybe we add some Signal R. So it's some extra infrastructure which we need. If we go into the server mode, basically because everything runs on the server, we can connect directly to a database or internal APIs, or we are already in like a private, safe environment. So I think that is one of the most cool features of Blazor. But what we also get is this circuit. So the circuit is basically the connection or the root of your application for one user, one session basically. And that is like, it has two arrows because it's two-way. It's a two-way connection. So if we run like a Blazor server interactive application, what you'll get is we have this server, and then every session or tab or browser is like a separate instance within our server. And then they all have with the circuit, they are being connected, and there's like a real-time connection to that. So what if we want to make this real time? We want to sync all these browsers. Well, basically because everything runs on the server, we have shared memory. So we could create a shared singleton, and then all those components can subscribe to that singleton, and then we can basically make that all sync and happen. So I'm just going to dive into the code now, and then let's just make a real-time app like in 5 minutes or so. Let me get to my solution. So basically what I have here, is it readable in the back? I think it's fine, right? Yeah, it's a big screen, so that helps. So let me get me to the solution. So what I did was basically I've got like a file new project of Blazor, like super easy because I wanted to keep it simple. So I did do a file new project of Blazor. Nothing special, so you would see there aren't even any NuGet packages or whatever. And what we'll add is a counter singleton. So it's just a class with a count. It has an increment method, and we're doing some interlocked so that because multiple threads will access it, so we need to make sure that if we increment that we are basically locking that count. And with a simple event handler for count changed, we can basically subscribe to a counter which changes. So then I extracted that counter example which you get to a component, which is the counter component, and I inject the counter singleton into this component. So it's basically inject that one because I registered it as a singleton in a dependency injection container. And then on the initialized async, we subscribe to the changing count. We set the current count based on that singleton. And then in the onChange, we just update the count of our component and say, hey, the state has changed. On the other side, if the component is going to be disposed, so then we unsubscribe so we don't have any memory leaks or whatever. So the cool thing is, with these simple changes, we already have a real-time web app. So let's run that. I basically, let me show me the home page. So here we're using that counter component, and I changed the world to NDC. So that's also a little change I did. So now we have this tab. So let me open a new browser. And then if we do click me, you will see it is being synced between those tabs. And that's all because we have this signal R circuit. So basically in 5 minutes you've got like a real-time web app. Cool. So now we have this real-time web app where we can sync some state. It's a counter, but you could imagine you could do a chat or a task. Basically, whatever you can think of which you want to make real time, adding a singleton in memory, and then it would work. But then we want to scale. Yeah, then that singleton, well, it's not really a singleton anymore. At least, well, it is on one server, but then on the other server, it isn't. Then we have two different counts. So if we want to scale to multiple servers, we need to have some synchronized state or whatever. So so we want to have this singleton working on multiple servers. So that is where Orleans can help us. So Orleans is a virtual actor framework, and then that's like making it everything more complicated in the sense of naming. But how Orleans helps us, it basically adds durable objects which are being distributed over multiple servers. So if we go back to our problem, having these two different singleton states, if we then add Orleans, it will basically create like a shared bucket or um, a distributed um, place where we can put objects in. So if we put that shared singleton into Orleans, then those different servers, or different components, they can basically reference that object, and then you'll get like a proxy so you can talk to that object. And Orleans will make sure that if you're on a different server and that object is on server A and you are on server B, it will basically know, oh, it is on server A, so I will redirect you to that location. So Orleans will make sure that the objects are distributed over multiple servers and that they can be found by an ID and that there's always only one single instance. So this shared singleton, well, naming in Orleans, it's coming from Microsoft Research. So they thought let's make it like not like a durable object or cloud native object or distributed object. No, we're going to call it a grain. That's just to make things more weird, but that's fine. It's a grain, and a grain is a actor. And what does that mean? So every grain or actor or object has a unique identity. That's the grain ID. So that's how you can reference that object. It communicates asynchronously with messages, and within Orleans, that means a method invocation. So async task, and then a response, and for example, async task increment. So it will execute that message, that method invocation, and then if we do a return, that's also a message back to the caller. Then the third thing is it is single threaded and single entry. So if it's executing the increment method, if there's a new call coming in, it will basically say, oh, stop, wait, we're already executing something. And then when that's finished, then it will basically take that from the queue and execute that. And the fourth thing with grains or actors is that they have basically private isolated state. So they're like object-oriented objects in memory. So something what Orleans adds is that they are virtual. So that means that the moment you call an object, it will activate it. So it will construct it and then activate that object for us. So for example, if we add this purple proxy, so we're saying, oh, we want to have this purple circle. We do a method call on it, and then Orleans will activate that object for us, and it will distribute that over our servers. Then, if we have like an extra proxy on a different server, it will see, oh no, it's already in memory, so I don't have to activate it. So basically, it will distribute that over our servers and make it accessible from everywhere. And they all have a unique identity. But the thing is, that would like fill up the system. Eventually, we'll have all objects in memory. Well, that's not something we want. So Orleans will basically deactivate or remove them from memory when they are inactive. So it has like a timer in it. So if If an object hasn't got any message or method invocation, it will remove that object after 15 minutes. That is the default, but it will it is something which is configurable. So you can also say, well, never clean up or clean up after this. So it's kind of like yeah. So it will deactivate, remove that from the system. So somewhere a proxy has been removed. It will stay in memory for a while, and then eventually the timer kicks off and it will be removed. It's like garbage collection, basically. So these green grains, because they're called grains, they live in a silo. Naming makes things difficult. I think it makes it more difficult, but they live in a silo, and that is run or hosted by a server, which is just ASP.NET Core or .NET. So what we can do, we basically can create a cluster of those silos with grains, multiple grains in it, and these servers, they need to know each other. So that happens in the cluster membership table. So all those servers are going to that centralized location saying, where can I find my mates? Where can I find my other silos? So after they retrieve that, it will basically, then they have like an interconnection between each other. And they will also check, is that one still alive or not? And they will register that all in the cluster membership table. If we want to connect to our cluster from another server which doesn't use Orleans, we can use an iCluster client, which also registers or checks the cluster membership table. Where can I find all the silos and connect to that? So it's really nice that we have a cluster and we need to have a table and we have got like networking happening. So with local development, use Aspire. So Orleans has amazing support for Aspire. Basically, you can do almost all configuration or top level configuration within Aspire. Aspire is like your configuration of your application with the infrastructure defined in C#. That's how I see Aspire, and it's mainly for local development. So let's look into adding a first grain to our project, or at least how does that look? Oh. So let's go into the second part. Let me stop this. Application, perfect. So the first thing we're going to look at is Aspire. So we have like this app host from Aspire where we say, oh, we've got a distributed application. I think they named it especially for Orleans. It's a distributed application. We're going to add some Azure storage. We're going to run it as an emulator, and I'm setting the ports explicitly so that I can easily connect with the storage emulator to it without configuring ports, because these are the default ports. Then I'm configuring a Azure storage table, and then I'm doing some Orleans configuration, and this is mainly just configuration. We're going to say clustering, use the table storage. So that's that cluster membership table. I'm also setting a cluster ID with a random GUID. That's mainly because if you don't do this, and then if you restart your application, it's going to see that membership table and think, where are these servers? Because they are part of that cluster. So if you stop and restart, it will think there are loads of dead servers which aren't there anymore. So then it will check, try to reconnect. So With this, I'm basically saying every time I start a new restart my application, it's a new cluster. And then here I'm having our web app, which is going to wait for the storage to start up. It adds the configuration from Orleans, and we say we've got 3 replicas. So we're going to distribute it multiple instances. So the next part is adding Orleans to our program.cs. So we're adding a keyed Azure table client with the same name as configured in Aspire. All that configuration will be injected by Aspire when we run it. And then we say builder.use Orleans. So there's also a builder.services.add Orleans. That one is not connected to, doesn't take the configuration from Aspire, so you should use this one. And then I'm adding a distributed grain directory, and that is for Orleans to know where all those objects are on the cluster. And some activity propagation, so that if you do a call and if a grain calls another object, you will see that nicely with OpenTelemetry. So then how does this grain, this counter, look? So we start with an interface, and that is because we have these proxies, right? So we start with an iCounter grain. You can name it whatever you like, but just to make it clear, it's a grain. And it has a marker interface saying iGrain with string key. It is literally a marker interface because it's empty. Then we have 2 methods, and they are both async. Basically, all your methods need to be async, so it can do queuing and use basically async await to handle that queuing. So I've got a getter for getting the count and an increment. Then here below I've got the implementation, and here we just have the current count as a private field, just object-oriented programming. And then getting the count, we just return it as a task from result, so that we adhere to our interface. And a very easy increment. And you can see I can just do increment by 1. I don't have to do locking or whatever, because Orleans will handle that for me. So then if I go into my component, I'm injecting the iCluster client. That's basically the one thing to rule them all, or to get access to everything. And on startup, we're going to say, oh, can I get the grain with this ID? So I'm saying counter ID is foo. Every grain has a unique identity. And we're going to load the current count into it. If we then just want to do a increment on it, it's literally just saying dot increment on that interface, and then Orleans is generating a proxy so that it will get to the correct location. And then on our home page, well, it's basically the same. I've added a basically the process ID, so that I know that I'm on a different server. Because otherwise you just see like Aspire forwarding it to the different applications. But this is basically to let me know, or you all know, which process or which server am I talking to. So yeah, let's run this. Cool, so it's starting up. So this is the Aspire dashboard. It will start up the Azure Storage Emulator. It will run that on Docker or Podman. I'm using Podman, but it's basically containers. It will start it up, and then it basically has 3 applications. You can see it's not really helpful in the sense of which URL you need to take or which address, because they're all the same. But the one thing important to show is it works with environment variables. So you basically see our Orleans cluster ID is being injected as an environment variable. We're going to say clustering, Azure table storage, it's called tables, and then some ports for the networking. So this is basically that configuration we did in the program.cs. So now if we open our app, well, we can say click me, well, and then I need to refresh because we don't have the sync back yet, but that just works. And then if we add a new browser, and this is like a lottery because it's sometimes you'll get connected to the same server, but you can see they are now in sync, but I need to refresh. Cool. So let me stop that. So now we have our first grain, and now we have it there, but we don't have the sync back. We don't have the real-time part. We just have the synchronization part. So there are 2 ways to add this real-time to our application with Orleans. So one of them is grain observers, and the other one is streams. So if we dive into grain observers, we will have our silo with the grain and observers, and then on the other side we've got our clients. And by on the client side, we can basically create a reference to our component by saying cluster client create object reference, and then we're going to pass in ourself, and it will basically create like a little proxy to that client object. Then we have this little object or this reference, and then we can pass it to our grain, put it in memory over there, and then basically adding the components as observers to our grain. Then if we want to notify, the grain can basically call methods on that reference directly. The only thing is, so there is not like a real live connection or checking whether that connection stays alive. So on the grain side, you've got like a helper class, the observer manager, which cleans up all these references after a desired amount of time, for example, 5 minutes. So after 5 minutes, if that's the thing you configured, it will basically clean up those observers because it doesn't know whether it's still there. So there's no like real, well, there's no check. Is it still there? So what you will need to do on the client side is also add a timer. And this is something you need to implement yourself. To basically do a keep alive. Oh yeah, I'm still there. I'm still there. And that's basically do a subscribe just faster than the expiration. So that's like some infrastructure or some code you need to write. But then it's basically from the observer direct invocation to the component, even if it's on a different server. So that's pretty cool. So on the other side, we've got streams. And with streams, it's more like the sophisticated solution, where the client will subscribe to the stream. It will basically say, oh, can I get this stream provider with a name? I want to have this stream with a namespace and an ID, and I want to subscribe to it. So what then will happen within the stream, or the stream implementation, is your subscription will be stored in a pub/sub grain, or another grain internal to the streams, and it will store it in storage, so it will keep track that or whether that subscription is still there. So you don't have this expiration going on. Then when the grain wants to send a message, by also getting the stream provider and saying with the same namespace and ID, basically saying on next, and then it will send that. What it then will do, what the stream implementation will do is it will queue it in a stream provider, for example Azure Queues or Amazon SQS or Event Hubs or Service Bus. And then it will store it there. You've also got like a memory implementation. And then you've got a worker which is going to pull those events, or multiple workers on every server. You've got workers, they will pull messages from the stream provider, and it will send it to the client based on the pub/sub. So basically that is basically the two methods. So we've got grain observers, which are like direct invocations back, and streams where we have a stream provider and a pub/sub store. It's a little bit more configuration, but it's more stable, and you don't have to do that check, or I'm still alive. It will also, so if it will send out a message and that client is not there anymore, it will remove it from the subscriber. So it will still clean up. You don't have to worry that if my server crashes, that it will stay subscribed. So that's fine. Cool. So let's see how that looks in code. So within this demo, I've got it with streams. So let me. So within Aspire, within our app host, we basically added. I want to have memory streaming. We give it a name, default streaming, and we're adding grain storage with the name pub/sub store. So this is where it will store that data or all the subscribers. I'm using memory streaming because I'm using these streams for notifications to the client, and I'm fine if I miss messages. If we miss messages, that's fine. It will just update, or the user needs to refresh. If you want to do streaming between grains and you don't want to miss anything, well, use something which actually stores it. But yeah, the subscription will be stored within the pub/sub store. So it's like you can choose how that all works. And then if we go into our program.cs, you don't see anything changed. Basically, we still have our tables and use Orleans because all this configuration is injected. The main thing is you need to add package references, but it will just crash completely if you don't add these package references and say, oh, I'm missing this provider. So there's some magic going on. I don't really like magic, but it will at least tell you that this magic is happening. So then if we go into our grain, basically on activate, we're going to say, oh, can I get this stream provider with that same name which we configured? I want to get the stream with the namespace iCounterGrain. I'm just using the grain as a namespace. And then get the primary key as string. So every grain has an identity, and we're getting that. Then if we do an increment, we're going to say stream on next, send the count with it, and then we basically send that notification out. Then if we go into our component, you see we injected the Orleans client. We're adding a using. And here's a little bit more going on, or at least it's a little bit more code. It's this, but we're going to say Orleans client or cluster client. Can I get a stream provider? Can I get the stream? So this is basically the duplicate code, the same code as we do in the grain itself. And then we're saying subscribe async, and within the on next, we do an invoke async and update our count. We also get a subscription handle, which is being used in the dispose. So when the component is basically removed from the document object model to unsubscribe. But even then, if it will do an update and it's not there, it will also unsubscribe automatically. It will only do that for things which are outside Orleans, so components, for example. If a grain subscribes to a stream, it basically, if it's not there, it will just activate it again, because that's how Orleans works. It will activate if something is not there. Okay. And in our home, we again, well, it's the same count component. I've added a parameter so that I can also add a second counter. So let's do that as well. Foo and bar. And then let's run that. Cool. So again, that's starting. You can also say within Aspire to don't shut down the emulator, but because I've got it in 4 different like projects, if I would do that, then some weird things will happen. But you can say, oh, just keep it running. That just saves a little bit in booting your application. So again, if we look at what it will inject, it will basically say streaming provider is memory, and it would also say, oh yeah, here grain storage pub sub store, use Azure table storage, and for the pub sub store you can retrieve it via tables, so that name as how it is registered. So let's open up our app, and then going to do a second window, localhost 7000. Cool, I'm lucky today. So now you will see if I update, we're on two different processes. They will basically keep in sync. So yeah, I can add loads of components. But basically, what you can do is add these components, just sprinkle around your application, and they will keep in sync for everyone who is subscribed to that object. So then you can still do your security checks or access checks just in your front end or at your component. And then after that, Orleans will make sure they will be in sync. And we don't have to think about locking or any other things. Cool. So we basically have solved our problem in the sense of we can now scale our application, and we can have shared state with those grains, and they will all be synced back to all the different browsers. So one thing though, because these grains are like virtual, they also can get like deactivated. So they will be removed from memory after they haven't been used. So we will basically lose track of our count. Yeah, that we don't want that to happen, of course. So that is why we have there's also like storage, and I think this is an important thing because it's really abstracted away within Orleans. It's pretty okay, but yeah, we basically want to make sure that that is clear. So let me just show you real quick how we can add storage to our solution. Uh, so let's stop this application. And go into our storage solution. It's basically the same project, with just a little bit added. So let's go into Aspire. First, we'll see I'm basically adding. Oh, I want to have grain storage again with tables, and now with the name default. So it will again use Azure table storage, but if I want, I would also just say for storage.add blobs, color blobs, and then I can say, well, we're going to use blobs, but um, let me not do that now because otherwise I'll maybe miss a NuGet package for anything. So we're just going to use tables, and then in our program we again didn't change anything because this will all be injected as configuration. And then in our counter grain, I'm adding a class called grain state, and for tables, what it will actually do, it will use Newtonsoft JSON to serialize this object and store it in table storage. Then to get it in my grain or my counter, we have this attribute saying the state name is counter. You can put in whatever name you want, but it's if you have multiple state things for your grain, you basically can give them multiple different names. So then we say the storage name, so that is default. That's the one we configured in Aspire. And then we have this class or interface called iPersistentGrain with the state. And Orleans will make sure that when it boots up your grain, it will populate the state from the storage. So Orleans will do that automatically for us. So I removed the field count and I'm just reading it from the state. And for the increment, I'm just also update the state and then saying write the state to table storage. Then this is the same code using default streaming and sending it to our components. So this for me, this feels like a big black box, and I don't like that. So eventually when you look into it, then okay, it's not that complicated, um, or but if we just look at the part which will basically populate this persistent state, if we want to do custom grain storage, yeah, let's add that, and then we need to implement the iGrain storage interface, and it has 3 methods. It's like a repository. So if you want to do your own storage, which I also do for my Galaxy Sweeper project, you basically get this iGrain state interface injected. That's basically your current state. which you need to populate in the read, need to write in the write, and well, clear state if you also want that. In my own project, I just didn't implement this because I didn't want to remove state, but that's basically the main implementation. So if you want to start using Orleans, for example, you can basically still use your database or whatever, implement this, and then you can start using it. So now that we have storage, let me run that app. So we're not going to use this customer search, we're going to use our table storage. Cool. So again, booting up. Tip, let it just keep on running. That just saves some waiting, but still pretty fast. So I've got like a foo t with a current count 2 and a bar t which has a current count of 8, which is coming from storage. And of course, if we do this, it will still stay in sync. So if I would restart the application, it will basically have the same uh, um, numbers, and we don't lose track of our counter, which is super important with this application. That's the main thing what it's doing. It's counting. So if we lose that, that's not something we want. So now we've added storage, and with that we basically have our application distributed over multiple servers. We have those objects being distributed as well over the servers. We have storage so that we don't lose track of our state. We don't lose state. And then we've got our streams, which will make sure that all those browsers stay in sync. So what if you want to add this to your application? So what do you need? Well, the first thing is you want to have like multiple servers. 3 servers. So the recommendation is to have either one, but then you wouldn't really need Orleans, or 3 or more. And that is mainly because they have like this check. If one goes down, then 2 can decide, oh yeah, we're still alive, that one is gone. If there were 2, then they just lose each other. So that's you need to have 3 or more servers. Then you need to have a private network, which so that's the second thing you need, a private network, so that they can safely communicate with each other. Because Orleans doesn't have like security within that internal communication, so you need to have a private network. But if you're doing something with containers, if you're running something on Kubernetes or on app service or Azure Container Apps, you basically already have this. So even with app service, you've got like the app service plan that has like its internal network. Then the cluster membership table so that they know each other. And probably you also want to have some storage, but that could also be your own database. So this is basically all you need to start using it and basically keep your applications in sync. So that was the end of my talk. So thank you all for having me. And I'm Sjoerd van der Meer, and the QR code of all the code is over here. It also contains a more sophisticated example with a chat or a customer support chat. So definitely check that one out. So cool. If you have any questions, come down here. That's just or now, yeah. So thank you.